Hi everyone, welcome to this video. Today I have got a very interesting and very important question when it comes to Python interview. The question is that you are given an array and they have asked that find the longest subarray with at most k distinct elements. Now, once you read this question, there are too many things to consume and to actually understand what they are asking. So let us try to break the question one by one. The question says find the longest subarray. First of all, let's discuss what is a subarray. Suppose this is a list or a subarray, list or array that is given to you. Subarray is basically a subset of this which is continuous element. So for example, let us say this is an array. So what is a subset of a valid subset will be something that is continuous. So for example, let's say we pick this 1 2 3 1 2. This is just a part of the bigger subarray and all the elements are in the same order which are present in the original array. So that is called a subarray. For example, if I pick something from here, let's say this is called a subarray. This is called a subarray. So 4 5 6 4 5 6 7, all these are called subarrays because there are two properties. First of all, it should be a part of the original array, okay, and second, it should be continuous in the same order in which it is present in the main array. You cannot say that, for example, here 4 5 and let's say skip, let's say 7. This is not a valid subarray. This is very important that you cannot skip elements. You really need to pick everything in the same order that is present in the main array. Now let us understand the second part of the question, that with at most k distinct elements. So for example, let us say we have we pick a particular subarray. Let us say we pick this. So it becomes 2 4 5 4 4. So how many distinct element does this contain? This contain 2 4 5. So total 3 distinct elements, right? So we want in every subarray identify the distinct elements, and this should not increase a given number k. So basically in the question you will be given an array and you will be given a number k. For example, let's say 2 3 whatever. So you have to find the longest of those subarrays, right? So for example, there will be multiple subarrays which will contain at most k distinct elements. So out of all those subarrays, you have to find the subarray which is the longest. For example, let us say if I look at here, now this particular subarray contains 3 4. This contains 3 distinct elements, right? So let's say this is subarray 1. This contains 5 elements, total 3 distinct elements, okay, and its length is 5. So let us say we want to find all the subarrays which contain 3 distinct elements. So let's say this length is 5. Now let us say I try to include this one. This will also contain 3 distinct elements, 2 3 4, and its length is 5. Okay, similarly we have to explore all the subarrays which contain. So if you see here 5 6 7 5 5 6. Now this particular array subarray, basically it has let's say S3. It contains 1 2 3 4 5 6. So although it contains 3 distinct elements, its length is 6, right? So far what did we see? We found that this particular subarray contains at most 3 distinct elements and its maximum it contains the maximum length out of these 3, right? Similarly, we have to explore all the subarrays which are possible with the given criteria. First of all, the first criteria is that it should have at most k distinct elements. Okay, this is the first criteria. And second is that out of those valid subarrays, whatever subarrays we found, we have to find the longest one. So I hope you understand the question now. Let us move forward with discussing the approach to solve this question. Now this question can be solved using two methods. I'll be discussing both of them in this particular video. The first one is the brute force method. That is, brute force means the most basic method, and where you count all the possible subarrays. So here we will I'll explain this method. We will count all the subarrays and then we will use the condition that is given to us. Okay, this is the first method, and the second method that we are going to use here is a sliding window method. Okay, now the second approach is more optimized, but make sure you first of all understand the first method, then you move to second. Okay, because second method is ideally the most ideal way to solve this particular question. But for example, let us say you are just starting and you don't understand things. So at least ensure that you understand brute force. Okay. After that, try to understand sliding window as well. In interview, if you can solve using sliding window, it will really give you a very good edge. But make sure at least you are able to solve this question. So I'll be discussing both of these methods in detail and try to understand both of them and see which one you understand and more, which one comes more intuitive to you. And my recommendation will be to solve using sliding window. But if you're not able to, at least make sure you are able to solve using brute force. So let us start with the discussion of the brute force method. So let us discuss the first method, that is called the brute force method. Now brute force method, the name might sound very daunting, but it means that this is the most basic method without thinking of optimization, without worrying about time complexity, without worrying about space complexity or anything. You discuss the most basic method to solve this particular question. So for example, the question says that you have to find the longest subarray with at most k distinct elements. So what we are going to do, we are going to break down this question. The first step will be that, okay, I have to find something. First of all, what will I do? I am given an array and so basically they have given us an array. This is my starting point. Okay. And I have to reach there where I have to find longest subarray with at most k distinct elements, right? Something like they have asked, and they have asked subarrays. So there are three criteria. First of all, we need subarrays. If you notice, first of all, we need all the subarrays. Okay. After that, what we will do, we will take down from these subarrays which all subarrays contain at most k distinct elements. And once we achieve all these particular arrays, what we will do, we will check from all these particular arrays. I will check the subarray with the maximum length. Okay. So that's how we are going to break using brute force method. So brute force method is all about breaking the question into as deep as possible and breaking it small steps and solving it. So what we have done, so there are three steps that we need to do. First of all, we need to identify which all subarrays are possible through this particular array. So let us say we identify 100 subarrays through this. Okay. After that, I'm just taking an example, right? Now let's say you identify 100 subarrays. Now in this subarray, there will be this contains all the subarrays. What do we need? Out of these, we want those subarrays which contain at most k distinct elements. So let us say such subarrays are 50 only. 50 subarrays are there which contain k distinct elements at most. Okay. Now for all these 50 distinct subarrays, what do I need to do? I need to find the length of each subarray, and then I need to check which length is the maximum. Okay. So I hope you understand that this is the basic intuition to solve this particular question. So now we will move towards the coding part where we will implement all these three things step by step. So here you have the array and you have given a k value 3. Okay. So let's write down step by step that what do we need to do. The step 1 that we discussed is to generate all possible subarrays from this particular array that is given to us. All possible subarrays. Step 2 will be to identify valid subarrays. So what do I mean by valid subarrays? Which contain at most k distinct elements. Okay. K distinct elements. Now once you have done this, the third step will be to identify the maximum length from these valid subarrays. So these are the three steps that I have broken down into. So step 1, generate everything. Second, filter out the valid subarrays. Third is from these valid subarrays, generate the maximum length. So let's do the step 1, that how to generate all the possible subarrays through this particular thing. Now let us discuss how to generate all the valid possible subarrays through this. So for example, what is subarray? What is a subarray? Basically, it contains a starting point I and it contains a ending point j. For example, let us say this is a subarray, right? So it will have, let's say, multiple length, right? So one will be starting point I and another will be the ending point j. So basically we need two pointers here, right? For in this particular, I need two pointers, let's say I and j. One will be the start of the subarray and this will be the end of the subarray. So what will happen? So let's say I starts from here, I equal to 0. Okay. Now j basically can vary from I to, so first of all, j will vary from equal to 0. Basically the first subarray will become 1. Okay. Now what will be the second subarray when I will remain 0 but j will become equal to 1. Okay, so it will become another subarray. Let's say this is 1, this is 2. Okay, similarly I will remain 0 and j will keep on varying. So for example 1, 2, 3, 4, right? So something like this. So this will be the first set of subarrays where I is equal to 0 and j will vary from 0 to, for example, whatever length is, whatever the length, the end point. Let's say this is n. So j will vary from 0 to n. Right now, of course, it is n minus 1 index, so j will vary from 0 to n minus 1. Now, what will happen in the second scenario? I will become equal to 1. Okay, now because we have taken care of all the subarrays which are starting from I equal to 0, now I will move for subarrays which start from I equal to 1. Now remember, when I is equal to 1, j cannot be less than I. That is very important to know here, because it is not possible that the start of subarray comes after the end of the subarray comes after the start of the subarray, because it will repeat, right? So if I cannot say that 2, 1 is a valid subarray, that is not possible. So j always has to, remember, j will always be greater than equal to I. Now what will be the second set of subarrays? They will start from 2. Okay, so first will be 2, second will be 2, 3. Okay, third will be 2, 3, then 1, then 2, and so on. So similarly, I will vary from 0 till the end point, and j will also vary. So I will vary from 0 to n minus 1 index. Okay, this is very important to know. So let's say this is 0, 1, 2 up to this is n minus 1. So I can vary from here to here, and j will vary from, remember, j will always start from I. J cannot start before I. So j will vary from I to n minus 1. This is very important to know. And using this particular, these two pointers, I'm going to generate all the possible subarrays that are present in this particular array. So let's move towards solving that particular part. So to generate the subarrays, first of all, I will define a blank list. Let's say call it subarrays, which is equal to blank. Okay, now this is my blank list. Now what do I need to? I need to create two pointers. As I mentioned, first will be for I in range, and this range will vary from length of, let's say, nums. Okay, so I will basically vary from 0 to n minus 1, just like we discussed here. I will be varying from 0 to n minus 1, and inside this we'll be running another loop where we will define another pointer j. And where will j vary from? For j in range, now j will always start with I. Okay, that is the key part here, and it will go till length of nums. Okay, so this is the scenario that where we define two pointers I and j, and they will always start with this particular point. So now what do we need to do? We need to always, for all the possible combination of I and j, we just need to slice the original array with I and j, and we just need to append to main subarray. So what we will do? We will do subarrays dot append. Okay, now we have this particular nums. Okay, so what I will do, nums, and I simply need to use a slicing. Now simple I, j. So every subarray will start from I and it will finish at j. Now, so I'll be using j plus 1 because j plus 1 is not considered. That's why it will be taken till j. So that's how you will, now this particular method will generate all the subarrays. Remember, you're taking all the possible I and j and you're slicing this particular nums with different I and j levels, and that's it. So now when we try to print subarrays subarrays. Let's see what it shows. Okay, so you see that we have got all the subarrays which are present in this particular list or array, you can say. Okay, so this was our first step. Now let's move towards the step 2, where we need to filter out the subarrays. So step 1 was to generate all the subarrays, and step 2 is to filter out valid subarrays. So to identify the valid subarrays, what we are going to do, we are going to create a dictionary of all these particular arrays which are present in this, all the elements. So we will create a dictionary, okay, where we will store all the distinct elements. So basically and its frequency. For example, 1 is there, okay, then there will be, so let's say its frequency will come. For example, 1 is coming out here, 1, 2, total 2 times, okay. Then I will have 2. Let's say 2 is coming 1, 2 times, okay. Similarly, I will like put all the numbers 1, 2, 3 up to 7, let's say, whatever are there, right? And so once you have this particular dictionary which contains the number, for example 1, then its frequency, let's say 2, its frequency 2, and so on. 7, its frequency 1. Now if you take the length of this particular dictionary, what is it going to do? It is going to tell you the number of distinct elements which are present in that particular dictionary, number of distinct elements. Now think a little bit. If you are able to get the number of distinct key which are present in this particular dictionary, that is technically the number of distinct elements which are present in the original array, right? So we are going to utilize the concept of dictionary here. So let us solve it here. Now, first of all, what we will do, we'll create a blank list valid underscore subarrays. Okay, let's say this is equal to a blank list. After that, what I'm going to do is simply I'm going to iterate through all of the subarrays which are present here. Okay, so what I will do for subarray in subarrays, okay, I'm going to go through inside each of the subarrays. Okay, now for each subarray, for each subarray I'm going to create a dictionary. Okay, so what will I do? I'll create a frec for each subarray which will be initially equal to blank. Okay, now this is initially blank. After that, what I'm going to do, that inside each subarray, if you see, let's say this is a subarray, we have multiple numbers, number 1, number 2, number 3, right? So what I'm going to further loop in. So I will say that for num in subarray. So first of all, in the main list, I'm iterating through all the subarrays one by one, and inside each subarray, I'm iterating through each of the element, each of the number that is present. Now what I'm going to do, presently my frec is empty, so I'm going to use this method which is frec, okay, frec and num. So what does this tell you? Frec nums tell you the frequency of this particular number in this particular what is the value of this particular key in this particular frec that we are creating. Okay, so frec num is equal to frec dot get num comma 0 plus 1. So let me tell you what does this mean. Now this particularly means that in the each of the subarray, for example this, you will go and you will check whether the number is existing in this particular dictionary or not. If that number is not existing in that dictionary, you will return 0. Okay, now if that number is not present, you are simply returning 0, then and you are increasing its frequency by 1. So basically, whenever you encounter 1 for the first time here, so what will happen? Let us say I talk about 1. Now 1 is not present in frec, so it will return you a 0 here. Okay, now once you get a 0, you'll increase its frequency by 1, because now after this my frequency of 1 increases to 1. Now what will happen in the second scenario? Once you identify for example, its value will be stored as 1. Now in the second scenario, what will be happening, that let's say you find the number here, second time 1. Now second time it will first of all check the frequency of the number in this particular dictionary. It will return as 1, and 1 plus 1 will become equal to 2. So that's how you are going to basically generate all the possible things which are giving you the result. Now, once this is done, we are simply going to check the distinct elements. So what I'm going to do, I'm simply going to do if length of frequency of this particular subarray is less than equal to k. Okay, if this is less than equal to k, what is given, what I will do, I will append this to valid underscore subarrays dot append, and I will append this subarray. Okay, so this is the step number 2. Let me revise it to you once again. So first of all, what did we do? We created all the subarrays. Then in each of the subarrays, I am iterating through each of the number. And in each of the number, I am using this concept of dictionary, where if the number is already present in the dictionary, I am getting its frequency with this method, and I am incrementing it. And if the number is not present, and whenever I encounter number for the first time, I am getting a 0 from here and I'm incrementing it by 1. Okay, so once this is done, after that I'm just checking if the length of that frequency here, if the length of this particular frequency that we am getting it is less than equal to k, then I'm simply generating the appending it to the main element. So that's how it is done. Now I think I need to just simply do it this way. Yes. Okay, so this is how it is done. So now I will print valid underscore subarrays. And I will remove this, and now let me run this. So I have got all the valid subarrays. If you notice, each of the subarray has at most 3 distinct elements. So none of the subarray contains more than 3. For example, this is 5, 6, 7, 5, 5. This is 4, 4, 5. So none of this subarray contains any subarray which has more than 3 distinct elements. Now let's move toward the step 3. The step 3 is to generate the length of all the above valid subarrays. So basically generate length of above valid subarrays. Okay, and from this get the max length. Okay, so this is our objective. So what will we do? First of all, we will create a max length. We'll initialize it with 0. Okay, just like we do. Then we will iterate in the valid subarray. So for subarray in valid underscore subarrays, what I'm going to do, I'm simply going to do max underscore length is equal to max of 2 things, right? So now because I'm iterating through each of the subarray, I will initialize a max length equal to 0, and then I will check the maximum of each of the length. So what I'm going to do, the max length will be basically max of max underscore length, and the second part will be the length of this particular subarray that I have created. Okay, so first of all, it will get 0 and 1. So now it will be the max length will be 1. Then it will go till this. Then it will go till this, right? And similarly, you will loop in through all the subarrays one by one. Now, once you are done with this, you've got the max length, and you can simply print. You can say the max, the length of max or longest subarray with at most k distinct elements is, you will say, max underscore length. Okay, so that's how you will do, and that's it. So this is the code. So right, so we did all the step-by-step process. The first step 1 was generating all the subarrays, step 2 was to filter out valid subarrays, and step 3 was to generate the length of above subarrays and get the max length. Now let's run. So let me just run this. So let's see what length comes in. So the maximum, the length of the longest subarray with at most k distinct element is 6. Okay, so that's how you have achieved this particular result. So this was the brute force method, right, where we broke our steps into multiple sub steps and we calculated it. Now the time complexity for this particular method will of course be higher O(n)² because we are using further iteration, like two loops inside each other, right? So now this next method, which is an optimized version of solving this particular question, is called sliding window technique, okay, where we will solve the particular question in O(n) time complexity. So let's move toward discussing the second part. So the second approach that we are going to discuss is called the sliding window method, through which we will identify the longest subarray in single run only. Basically, we will iterate. So let's say this is the array that we are having. Okay, we will iterate from start to end using one single pass, and we will get the maximum length of the subarray, basically, which contains k most distinct elements. So we remember we are going to keep a track of few things. So first of all, we will create a current dictionary. Okay, now what will this dictionary be? That we'll be creating a dynamic window, okay, which will start at, so it can consist of one element, two element, three element, right? So for example, let's say it consists, this is the dynamic window right now. So for each dynamic window at any stage, I will calculate which all keys are there, which all distinct elements are there, and what are their frequencies. Okay, that is what I'm going to store here. Okay, so let's start understanding this concept from the most basic level. So let us say you start from this particular, so what you're going to do, you're going to start from the left of the array. Okay, you will start from the first element. Now remember, this is your initial, you can say this is your first subarray, or you can say initial window, which contains only first element. So let me just mark it as yellow. Okay, now now in this particular let's say this is the first subarray. Now how many keys are there? So there is a key 1 present in this, okay, and it has a frequency of 1 so far, correct? So it is a frequency of 1 so far. Now remember, I can go up to k distinct elements. So I'll be using a concept of expansion, window expansion and window contraction. So window will expand whenever I see that number of keys are less than the value of k. For example, here I have only one key in the current dictionary, in the current window right now. Okay, now, so what I can do, I will expand the window towards the right till I get k distinct keys. So for example, here k's value is equal to, let's say, 3. Okay, so we are given that the value of k is equal to 3 here. Okay, so now what we will do, we will expand this towards the right. So I'm going to say that I'm going to include the element 2. So now what happens, I have the second key as well, which has the value of frequency of 1 so far. Okay, so presently I'm keeping a track of the frequency of elements in this particular window that we are having. Okay, now I see that still number of keys are still less than k. So I will still again expand this. Now I will get the third element as well. Now I've got 3 distinct elements and its frequency is 1. So far it's good. Now I see that it is still 3. Now it is valid for me because I can have up to 3 distinct elements. So what I will do, now I will further expand. So now if I get the next element as well, I see that it has 4, although this current window has 4 elements, but this number is getting repeated because the 1's frequency will get to 2. So the number of key still remain to be 3. So I will still expand it. Okay, now in the next expansion, what do I see? I see that, okay, I get this particular 2, right? So now again the frequency of 2 becomes 2, right? And so basically we have got this. Now in this particular window, we see that the length of this particular window is 5. So what is the maximum length that I have seen so far? Length is equal to 5, right? So far I have seen a maximum length of 5 where number of distinct element remains to be 3, correct? So I will just store it here. Okay, now so far the max length is this. So I'll say max underscore length is equal to 3. So this is the max length. So far it is, sorry, 5 is the max length that I have got so far. Pretty cool. Now what do I need? Simple. Now I will further expand because I have 3 keys till now. I can still expand. Now what will happen? The moment I expand it to next element, right? The moment I do here, I see that my number of keys will become more than k. Okay, so what do I have to do now? I have a constraint that in my current dictionary I cannot keep something. I cannot keep more than 3 distinct elements. So what I will do, I will remove the leftmost value which is present in this particular window. So what I will do, I will remove this one. Now once I remove this particular one, there will be 2 things in my current. So I have to reduce the frequency of this by 1. So when I reduce it by 1, so 1 is still there, but now it is a frequency of 1. Okay, now even after doing this, what do we see? That I see that still I have 4 distinct elements. Okay, so I still have to reach to 3. So again I will remove an element from the left. So if I do that, now let me remove an element from the left. Now I will remove this. So what will happen? Technically the frequency of 2 will decrease by 1. Okay, this happened. Now still the number of distinct keys in my particular subarray is still greater than equal to 3. So what do I have to do? I have to still contract it, right? So if I see 1, 2, 3, 4, so I have to still contract the window from the left. Now I will remove 3 again. Now once I remove 3, it will become 0. The moment the frequency of any element becomes 0, I have to simply remove it from my current dictionary. Okay, so that my dictionary at any time contains 3 elements. Okay, so this is my new window. Now this window has a length of 3. Okay, so now because this window has a length of 3, I will compare it with the maximum length that I have so far. Now I see that my maximum, so let's say this is the max and this is the current. Okay, so this is the current value. So current value 3 is less than my maximum value. So I will not be changing my max value. So what I will do now, this is the updated window which has 3 distinct elements, and so I will basically move it from here to, so move from here to here. Okay, now I have this particular element. Okay, so now what I will do, I will move to the next. Now I will further expand because I have reached a condition where I have 3 distinct keys and I'm good with it. So far the maximum length that I have seen was 5. Okay, now I will change this max length only when I see a subarray which has a length of greater than 5. Now what I'm going to do, I'm going to further expand it. So now let's expand it. Now I get an element 5 with a frequency of 1. So what will happen now? Now number of elements become greater than k. So I have to remove the leftmost element. So now I will contract from the left. Now because frequency will become 0. Now the moment frequency becomes 0, I have to remove it from the dictionary. Okay, so that is what's going to happen. So this is the important concept here, that this dictionary is dynamic. For different arrays it is different. Okay, now I will further expand this. Now let's expand this particular part. Now I will go here. Now what will happen? The frequency of 4 will become 2. So I am valid with it. The current length is 3, so it does not, it becomes 4, but it is still less than 5. So I will not be changing it. Okay, now let's expand to right once again. I got 4. The frequency of 4 will become equal to 3. Okay, I still have 2, 4, 5, 3 valid. So the current length becomes 5. Now 5 is not greater than max length, so it will still remain same. Now I will include the next element. Now what do I see? That the frequency of 5 becomes 2 and the total length, total number of length of this particular array that I am having, it becomes 6. So now because current length is greater than my max length, so I will update my max length towards 6. Okay, so far the maximum length of any subarray is 6. So that's how I've done. Now I will further now because I have got this reached this particular level. So what I can do is I can contract. I will try to contract from here. Oh, sorry, I will try to expand from left, because I have to increase the length, right? I remember I have to get the longest subarray. So I will keep on expanding till I get the longest. Now my next target is, can I get a subarray whose length is greater than 6. So what I will do, I will include the right part. Now the moment I include the right part 6, 1, I see that the number of frequency become greater than 3. So what do I have to do? I have to remove the leftmost element. So when I remove the leftmost element, the 2 will go, 2 will become 0. Now because it becomes 0, I will remove it. Okay, and this will be my updated dictionary. Okay, now what do I see? The length is still 6, so it is not increasing in 6. So my maximum longest subarray's length is still 6. Now what do I have to do? I have to include the next element. Now when I include 7, the same thing will happen, because 7 will come here, its frequency will be 1. Okay, now frequency becomes 1, so it becomes greater than this. So what I have to do? I have to remove the element from the left. Now once I remove element from the left, the force frequency will become 2. Now it still contains more than 4. So 4, 5, 6, 7, it contains more than 4 elements. So what do I have to do? I have to still contract from here. So I will contract it. The frequency of 5 will become 1. Now this again still contains more than 3 elements. So what do I have to do? I have to again contract. Now once I contract it, the force frequency becomes 1. Now still this contains more than 3 distinct elements. So I will again contract 4 from the left. So now once this happens, 4 becomes 0 and 4 will get out of the dictionary. Okay, so 5, 6, 7 is my latest key in this particular thing. So now what will be happening? So this particular, now length of this particular is 3. Now 3 is not greater than 6, so simply I will not update. My max length still remains to be 6. So now what will I do? I will include the next element. So let's go here, include the next element 5. Now 5's frequency becomes 2, the current length becomes 4, but it is still less than the max length. So I will again include the right, expand it. 5 will become 3. Okay, this will become 5, but it is still not greater than that. Now I will again include 6. Now once I include 6, my frequency becomes 2 for 6, and current length becomes 6, and the max length remains to be 6. Now what do I see? That slowly from the left, I have totally moved towards the right. This is my window, and this is the maximum window where I can go up to, and its length is still 6. So the maximum length of any window of any subarray that I have seen with the given condition is 6, and 6 will be my final answer. So this is the whole, I will say, visualization, that strategy that we are going to follow. We are going to create a dynamic window which will expand whenever it has met a criteria that current dictionary elements are less than equal to k. Okay, and it will contract whenever the current dictionary element length are less than become greater than equal to k. So this concept we are going to use, and in one single iteration we will be able to identify the max length that we are having, and that is the logical approach. So I hope you understood this. Now we will move towards the coding implementation of this. Now let us see the coding implementation of this sliding window technique. Okay, so we discussed the architecture. So now let's write down the overall blueprint on how we are going to solve this particular question. So what I will basically need, so step 1 will be that I will need a left pointer, okay, and I will need a right pointer. Okay, now right pointer will be used to expand the window, and the left pointer will be used to contract the window. So this is what I'm going to do. Okay, now because whenever I need to contract the window, I will shift left pointer from left to 1 by 1 point, and whenever I need to expand, I will shift the right pointer toward the right. So that is I'm going to do here. Now, so first of all, this is this. Okay, so what I will do, I'll start my left pointer from 0. Okay, I will initialize the left pointer equal to 0, and right pointer will be basically moving throughout the, so right will also vary from 0 to n-1. Let whatever the index will vary from 0 to n-1, and left will be initialized at 0. So what is going to happen, that we will start with I equal to 0 here, and j will also be 0. Okay, now j will keep on, suppose, expanding. Okay, now let's say a time comes when my window size is this. Let's say it was 1 2 3 1 2. Okay, this was my window. Now this is my I, this is my j. Okay, now j was expanding to increase the window side. Now whenever I move to the next point, because when I include the element 4, I see that the number of distinct elements become greater than 3. So I will contract my I. So basically I will reduce it from here, and this will be my updated I. So technically what I'm doing, I'm increasing my left pointer by 1. Okay, so that is what I'm going to do. J will vary from 0 to this particular point, and I will be only used whenever I have to contract the window. So these are the two operators I need. Now beyond this, I need to keep a track of all the frequency. So also I need to keep a track of frequency. So I'll create a dictionary to keep a track of distinct elements which are present inside that current window. So that's what I'm going to do. Okay, so let's start coding this particular question. The first thing what I'm going to do, let's write down a function def longest subarray. Let's write down it like this. Okay, and so what will be the input to this? The input will be nums, and I'll be passing k. Okay, so the nums is an array, and k is whatever the maximum value of k you want to be there. So let's create this function. The step 1, so what I'm going to do, create a blank dictionary. So step 1, where I will create a blank dictionary, because so far I have not started the window. So I'll say create a blank dictionary. So what I will do, let's call it frec equal to blank dictionary. This is what I have created. Now I need to initialize the pointers left equal to 0. So I will say left equal to 0. Okay, and remember max length, I also need to initialize one more variable, max length. Presently I have not started iterating, so I will keep max length equal to 0. Okay, I will be changing this during the course of the question. So these were the basic initializations I needed. Now let's start with the iteration. So iteration will happen with the right pointer. So for right pointer, let's say in range length of nums. Okay, this is where I'm varying, because my j will vary from here and it can go up to this particular point. So that's how I'm going to do. So this part is done. Okay, now what I need to check, remember there will be two conditions. Whenever a new element, I see a new element, for example, whenever I see a new element, there will be two conditions. If that number is already present in my dictionary, I will increase its frequency by 1. And if that number is not present, I will simply add that element for the first time. Correct? So what do I mean to say that? For example, let us say I create this dictionary which is blank enough. Now whenever I see, because I'm seeing 1 for the first time, so I will initialize value of 1 with 1. Okay, now let us say 2 was 1 and 3 was also 1 with this way. Now whenever I see the next element 1, so now if the value is already present in dictionary, what do I need to do? I need to increase the frequency by +1. Okay, so this concept I'm going to use to create this dictionary, that whenever you encounter a new value, you will increase the count in dictionary by 1, and whenever you encounter a totally new value, you will set the value of that particular key as 1. So that's what I'm going to do now. So now let's write down that if nums, okay, so sorry, if so we need to do if nums of right, okay, because we are iterating in nums, if this particular thing is present in my frequency, right? So if any number is present in my frequency, what do I need to do? I simply need to update frec of array of, nums of right pointer by plus equal to 1. So what did I do? That frequency of this particular element, whatever number I'm going to, so this is the number. If this number is already present in frequency, I'm going to increase its frequency by 1. Okay, else what I have to do, I'll simply set the frequency of that particular number as 1. So this is the first right. Now with this, my dictionary will be created. Okay, now this part is done. So I will keep on, so this way dictionary will keep on increasing, reducing, those things will be happening. Now next thing what I need to do is, for every basically number, there will be few conditions, that whenever the length of my frequency becomes greater than the k that is given. So here I'll say conditional check. I'm going to use this. So conditional check says that whenever, so for example, whenever the length of your, while the length of your whatever current window that you have created, right, with length of frequency. Okay, what does length of frequency give? It gives the number of distinct elements which is present inside your current window. So what do I mean to say? That while creating this particular window, whenever you encounter that the length of this window becomes greater than equal to k, so what do you need to do? You need to do two things. So remember this thing: whenever my length increases, I need to do, first of all, reduce the frequency, so remove leftmost element. Okay, leftmost element. So let me just increase the font size. Okay, so remember, whenever I see a criteria that the number of elements in my dictionary, let's say they become greater than equal to 4. So first of all, what I'll do, I'll remove the, so if you see 1, 2, 3, 4. So whenever I see such condition, what I have to do, first of all, I have to remove the element from the left hand side. So technically remove the leftmost element. Second, reduce frequency of that element by 1. So for example, we had 3, 1, 2, 4, right? Let's say 3, 1. So let's say this was our window. Let's assume this was our window. 3, 1, 2, 4. Okay. Now each of the element was 1, 1, 1. Okay, 1. Now the moment I encounter a 4, I have to remove 3 from it. So I will first of all remove 3 from here. So what happens? First remove and reduce the frequency by 1. So frequency becomes 0. Now whenever if frequency becomes 0, what you have to do? Remove the element from the dictionary. So I will say that if frequency becomes equal to 0, then delete element from that particular window. So that's what we are going to do. So 3 conditions: whenever you see your length of the dictionary becomes greater than k, first of all, you will remove the leftmost element. Second, you will reduce the frequency of that element by 1. And if the frequency becomes equal to 0, you will technically delete the element from that particular dictionary. So I will basically delete it from here, and that's how my thing will work. So let's try to implement this in my code. So let us try to implement that logic here. So while the length of frequency is greater than k, I need to do few things. The step 1 will be, I will remove the element from my particular dictionary. Okay. So whenever I have to remove the element from a particular dictionary, what do I need to do? So for example, this was my element, right? Let's say this was my window criteria. Now, whenever I see an element, I have to reduce the element from here. So I will reduce, basically in the frequency window, I will reduce the frequency of the leftmost element by minus equal to 1. So this is what I'm going to do. Okay. Remember, we have to reduce the frequency of the leftmost element. We do not need to touch the rightmost element because I'm removing my left element. So let's try to implement this in the code. So while the length of the frequency is greater than 2, first what we will be doing, we will say that frequency of let's say nums of left, this will become equal to 1. So basically we are reducing it by 1. So reduce, so what does this mean? Remove leftmost element, leftmost element and reduce frequency by 1. Okay, so far I have only reduced the frequency by 1. I will remove this particular by moving left pointer by 1 in the next step. So this is done. Now remember, I have a criteria. If the frequency of that number of the left becomes equal to 0, I have to simply remove it from the current frequency. So what will I do? If frequency of array, sorry, if frequency of nums of let's say left pointer, okay, this becomes equal to 0. So let's say this become equal to 0, what we will do, remove the element if its count becomes 0. Okay, that's what we are going to do. So if this is equal to 0, so now if this happens, what do I need to do? I need to delete. So let me just go here, delete. So what I will be deleting? Frequency of nums of left. Okay, so I will simply remove this element. I will basically delete this element from my current dictionary. Okay, so first of all, I will reduce the value by 1, and if the value becomes equal to 0, I will basically delete the element from that particular frequency that is given to me. So, and after this, what I will be doing, I have to remove the, I'll shift my left pointer by 1. Okay, so why did we do that? Because in this window, once we have reduced so in this window, once we have reduced the frequency by 1, I have to shift my left pointer from this to this, because I have to contract the window. And how do I contract the window? By moving left pointer towards by right by +1. Okay, so this is how it is done. So this was the conditional check, and now comes the last part of this particular code, that okay, so I have got everything now. Now what do I need? I need to get the maximum length. So I will say that update, I'll say update max length. So how to update the max length? I will say that max underscore length, it has to be max of two things. Whatever my current maximum length was there, okay, as I mentioned, whatever my current maximum length is there. And now let's see, whenever we have a window, what is the length of that particular window. So for example, let us say you have, so let me just first of all remove all this. Let's say you are at a particular window. Let's pick up any. So for example, let's say you are at this window, and let's say you want to, how do you get the length of this particular window? So this is I equal to 0, 1, 2. So this becomes, so 0, 1, 2, 3. This becomes I equal to 3, right? This becomes I equal to 3, and this becomes j equal to, so 3, 4, 5, 6, 7, 8. Okay, this becomes j equal to 8. So how will you get the length of this particular window that you are having? So remember, what do you have to do? So for example, let's say we have these two things. What is the length? It is 2. So the difference will be j minus I plus 1. So for example, this is 8 minus 3, 5 plus 1. So the length of this particular window becomes 6. Okay, so now as I am moving through the various windows in my particular array, the size of window will always vary. So the length of any window at any time will be j minus I plus 1. You can try using any, for example, let's say you just take first, let's say this is my first window. Okay, so I is 0, j is 0. What is the length? Length is 1. Now let us say I increase. I is 0, j is 1. So 1 minus 0, that is 1 plus 1. So length becomes 2. That's how it goes. So whenever you have two pointers, you have left point index and the right index, the length of that particular subarray becomes equal to j minus I plus 1. So in any particular window, either I will check the max length which was there till now, and or I will check from right minus left plus 1. Okay, so either it has to be this or it has to be this. So that's how we're going to do this. And in the end, what do I need to simply return? I need to, so I simply need to return max underscore length. Okay, that's it. So that's the question all about. Okay, now let's just review it from start to once again. First of all, we initialize few pointers of blank dictionary, a left pointer and a max length. Then we are iterating through all the list. Whenever I see a new value, I will increase the frequency by 1, and whenever I see a repeated value, whenever I see a new value, I will set the frequency to be 1, and whenever I see a repeated value, I will increase the frequency by 1. Now this I will keep on doing till my length of frequency is less than k. Whenever it becomes less than equal to k, whenever it becomes greater than k, what do I need to do? I need to remove it from the dictionary, right? And then if the frequency becomes 0, I need to drop the number from the dictionary and move my left pointer towards 1. Okay, I explained all this through the visualization. So while writing the code, try to visualize as well. Okay, and after that I will just simply need to return what is the maximum length, that is max length current, and the right minus left plus 1. So this is the code. Now let's just try to check. Then we got 6 in the previous case, so let's see what do we get. Okay, so I'll call this function longest subarray, longest underscore subarray, and it's nums slash k. Okay, so we have this nums slash k, and let's see what do we get here. We got 6, right? So in the previous case also we got the length to be 6. So this is how you will be doing this particular method using the sliding window technique. I know this is little bit complicated if you are doing it for the first time, but trust me, this is very optimal solution because you are just iterating through the window only once. So what you're doing, you're first of all defining a window, right? And you are increasing whenever you see that, okay, my conditions is getting satisfied, you keep on increasing the window size. And whenever you encounter a numbers like 4 here, which reduces basically, which changes the condition and which does not validate this particular criteria, you contract the window from the left. And by doing so and so, right? For example, you increase now 2 3 4 2 3 1 4, so you will again contract. Okay, now you will see 3 1, there are still 4 elements, so you will again contract. Right now there are 3 elements, so you will increase to the next element. So like this you are doing. Now you got 4 elements, so you will again contract here. Okay, while doing all this, you will keep a track of maximum length because that is very important, right? So you'll do this 4. Now there are 2 4 5, so there are 3 elements. Now you can further get next element. Now you can get further next element, so you got 6. So this is generally the 6. The length of this particular subarray is 6, and it is a good condition for me. Now what I will do, I will have to increase the length by 1. Once again, the moment I increase the length by 1, what do I see? That the overall length number of distinct elements become greater than 3. So I will remove something from the left, right? And I will again, so 4, so if I see 4 5 6, 4 5 6, so this is also good for me. Now when I get the next element 7, okay, now the elements are 4 5 6 7, so I need to remove this 4 from here. Okay, now I see I will need to remove 5 from here. I will need to now remove 4 from here. Now I will need to remove 4 from here. Okay, now I have 5 6 7. Now I will I contracted the window. Now I will keep on expanding, expanded, and again expanded. Okay, so this is how it is done, and you will reach the longest subarray with at most k distinct elements. So this was a very good approach. If you are able to solve it using this method, it will really give interviewer very good confidence on you. So try using this, but remember, if you're not able to understand this, at least understand the brute force method. That is something you should be knowing. This is a very important question from interview perspective. It is that's why I'm covering here in detail, because you really need to understand all the ingoings of this particular question. So thanks for watching this video. Let me know if you understand the solution. Comment below the video. If you have any doubt, you can reach out to me. We will come up with more question in this particular series. This is just the second question. So please try to complete this series as close as possible. Try to first of all attempt the questions on your own, then see the solution, then try to attempt. Okay, the main thing is to remember these questions because these questions in many companies are asked straightforward. Okay, so even if you remember all these approaches, you will be able to at least tell the architecture of the question that, okay, I will do using this method. So at least if you're not able to solve, interviewer will get some idea, okay, you are thinking in that particular line, which is good. Okay, so thanks again for watching the video. I'll see you in the next video. Till then, keep learning.